Dear friends, welcome to the new session, moment generating function. Those who don't see the previous video moments, please click the description and use the link, go and see the moments, and then you come back to this session, moment generating function. So in the previous video, we learned what is meant by moments and how to solve the problems and the relation between raw moments and central moments, etc. etc. Now we are going to learn what is meant by moment generating function MGF, and using this how to find my mean and my variance. That's what this video content is going to be processed. Let's go. So what is the definition of moment generating function? So I am taking a random variable x. So let us consider x as a random variable. Then the moment generating function is defined as e of e power tx. So for all t belongs to minus infinity to infinity. So now the notation what we use is m of t or mx of t. So this is what the notation we use to moment generating function. So now what it comes into your mind immediately when I say moment generating function, what we have to do? We have to describe how it works in the discrete random variable and how it works in the continuous random variable. So let us go and explore the MGF in what? Discrete and continuous random variable. So if you say it as a discrete random variable, I'll take the points, okay, as x1, x2, x3 up to infinity. Okay, but in the case of continuous random variable, I will take x belongs to what? Minus infinity to infinity. So I have to mention this as DRV, discrete random variable, CRV, continuous random variable. So my formula here and here I am going to see one by one. So it is going to be summation over I, okay, we don't mention it as I is equal to 1 to infinity. I am going to take e power txi into the corresponding probability, that is small p pxi. So this is the formula for moment generating function for the discrete random variable. But in the case of continuous random variable, I would have the limit between minus infinity to infinity. So e power tx into f of x dx. That's it, guys. So we have to note that here in the both the case t is a parameter. Okay, t is a parameter. That's it. So now what you're going to do, we'll solve the problems using moment generating functions. Okay, so some basic formulae we need to solve. You know that 1 minus x whole power minus 1. Do you remember the formula? When mod x less than 1, then it is going to be 1 plus x square etc. up to infinity. If it is suppose 1 plus x whole power minus 1, the odd powers will become negative and the even powers is positive. So these are all some formulae we are going to use in the problem. So just now I am telling this. Okay, guys. So next we need to know the properties. As usual, properties are for MCQ, properties of MGF. Okay, so we have two properties. First, see the simple one. moment generating function, when I say c into x instead of x of t, that is equal to moment generating function with respect to x, I can take the ct there. Okay, this is the first property, and the proofs are not included in our syllabus, so I'm not giving the proof here, I'm just giving it as a result. Then if you have x plus c where the constant is multiplied here in the first one, now the constant is added here, it is nothing but to remove this I have to do like this, e power ct into mx of t, guys. So the proof is not very tough, but it is not needed right now, and it is very simple. Okay, this is one property. Now obviously if I give like this, suppose I am telling you m ax plus b of t. Okay, so you can simply say, so plus b plus c, we write it as e power ct, so we will be writing e power bt, and then this a can be put inside mx of at. Hope you understand what I am doing here. A, b are constants, that is very important. A and b are constants. Similarly we can do for what? The negative symbol. If it is minus here, it will be minus here. If it is plus here, it will be plus here. Okay, it depends on the sign. And there is another MCQ as usual. The fourth one property is, if x and y are two random variables, which are independent, if these two random variables are independent, then we have the result mx plus y. Whenever I write, it is equal to mx of t into my of t. Okay, so that's it, guys. So these are all the properties for MCQ. Now let us go into the problem. Let us jump into the problem and solve some problems which make you very confident for your exam point of view. Let's go. Okay, guys. Now I'll take a problem. So what I will do, I'll give a sample problem for discrete case as well as a problem for continuous case, which give you 100% confidence to solve the problem just like that. Okay, let's go, guys. Find the MGF. So they're asking to find the MGF for a random variable x. Okay, they don't mention whether it is discrete or continuous, but we clearly give how to clarify a doubt, like how to find whether it is discrete or continuous random variable. If you're little have any confusions or you forgot this, just click the description, go to the second link, you can go and see what is the difference between discrete and continuous and how to identify whether the function is discrete random variable or given problem is continuous random variable in our video 1, that is first video of discrete random variable. You just see it and come back. Okay, let's go. Find the moment generating function for a random variable x whose probability is small p of x, that is 1 by 2 power x equal to 1, 2, 3, etc. Hence, you have to find the mean and variance. That's it, guys. So now let us see how to find this. So it is a discrete random variable. Why? Because even the function is given, the data given as what? X equal to 1, 2, 3. Now 3 is given. The successor of 3 is 4. Then the predecessor of 3 is 2. So it is going to be a discrete random variable because It is infinite, but it is countably infinite. If I say x greater than 0, now I cannot say what is the number because it is uncountably infinite. If this condition is given, this problem is continuous random variable. Since this condition is given, it is a discrete random variable problem. So that is what the observation we have. Okay, so now let us solve the problem. The probability is given as 1 by 2 power x, and x varies from 1, 2, 3, etc. up to infinity. So now let us crack the problem. We use the formula for the discrete random variable. My E of tx, so that is my mx of t, that is moment generating function. So we know that its summation x equal to 1 to infinity, because the values are given x equal to 1 to infinity. It's simply e power tx into probability of x. So our case, the question is given as what? X equal to 1 to infinity e power tx, it is going to be 1 by 2 power x. Okay, done. So I said the formula, actually this is because our question is given between 1 to infinity. In general, you have to take whatever the limit given or whatever the data given in the question. Okay, so now I want to find the general term, I want to find the function, not the summation. So first of all, to find the function or the summation, we have to expand this, put x equal to 1. I'll be getting e power 1 by 2 power 1. X equal to 2, I'll be getting e power 2t by 2 square, e power 3t by 2 cube, e power 4t by 2 power 4, etc., etc., etc. Now, just now I said, what is the formula? I said a simple formula to crack this problem. 1 minus x minus 1. It's 1 plus x square, etc. up to infinity. Now let us compare this. Before going to this, we have to know something about the problem. So e power t into e power t, usually we express as what? E power 2t. Since the base is same, I'll add the powers. But in school days, when you multiply x into x, what do you say? You say x square. So here similarly, e power t into e power t, I can say it as what? E power t whole square, guys. Why? Because it is needed for me to crack this problem. So I'm just doing according to my need. Okay, let us see how I crack this problem. So first of all, I'll write this as e power t by 2 whole power 1. This e power 2t, I can write it as what? Now I will say it as e power t whole square. 3t means whole cube. 4t means whole power 4. So e power t, here also the denominator square, so whole square. E power t by 2 whole cube, etc., etc. It goes up to infinity. Now the problem is, I had the first term as 1, but here I don't have the first term. So what I will do, I'll take this e power t by 2 commonly out. So I'll be having 1 plus e power t by 2 plus e power t by 2 whole square, etc. So now it is in this form where my x value is what? E power t by 2. That's it, guys. So what can I do now? I am going to rewrite the problem. Simply my mx of t. My mx of t is going to be what? E power t by 2. This is going to be 1 minus e power t by 2 whole power minus 1. So e power t by 2, when I take LCM, 2 minus e power t by 2 whole power minus 1. Now when I take the reciprocal, it's going to be e power t by 2 2 by 2 minus e power t. So what would happen now? 2 get cancelled and we will be having e power t by 2 minus e power t. That is my moment generating function. So this is what we have to do, guys. We find the moment generating function for the given question. Good. What is the next part? Once you find the moment generating function, from the moment generating function, you are going to find what? Mean and variance. So now for that, what you have to know? You have to know first of all what is the relation between the moment generating function with mu1 dash or mu2 dash. What is the relation? So let us write that. Then you can understand. So there is a result mu r dash is equal to d by dt. So dr power dt power r of mx of t, that is equal to, so that means the rth moment, the raw moment or the moment about the point, it's the rth derivative of my moment generating function. After that I have to substitute t equal to 0, or simply we will say, for simplicity I am writing mx r, that means r time differentiate with respect to t, and then I'll put t equal to 0, or more simplicity I'll rewrite like this, r times 0. So this is the relation between moment generating function and the moments. Now let us go, keep this in mind, and we are going to solve the problem. Okay, so now you see what we found is mx of t is e power t divided by 2 minus e power t. So my mu1 dash is nothing but mx dash of 0 or mx dash of t at t equal to 0. So I want to find the first derivative of this. That's what I'm trying to say. Then my mu2 dash. So as I said, whenever nothing is given, it is considered as raw moment, and mu1 dash in the raw moment is what? Simply my mean, guys. And mu2 dash is mx double dash of 0. That is second derivative of t at t equal to 0. So right now my job is to find what? Mu1 dash and mu2 dash. Why? And very important, mu2 dash is not. Mu2 dash is not my variance. My variance of x is mu2 dash minus mu1 dash whole square. Okay, we should be very careful with this. So with this, let's go into the problem. Okay, so let me take this mx of t again, e power t, 2 minus e power t, that mx dash of t. So we have to apply what? U by v rule, v square, v du, u dv. Yeah, it's obvious. So 2 minus e power t whole square here, 2 minus e power t v du, and then differentiation of e power t is e power t. Then when I keep e power t and when I differentiate the denominator data, 2 is 0, minus e power t is minus e power t. That's it, guys. So now you see, since we need the variance, anyway I have to expand this, or simplify this. So if I take e power t outside, I will be getting 2 minus e power t plus e power t, because minus into minus plus, and my denominator is 2 minus e power t whole square. So this and this will get cancelled. So I'll be getting finally 2 e power t by 2 minus e power t whole square. Great. So I get what? My mx dash of t. So my job is now to find what? M double x dash of t, because we need to find mean and variance. Okay, we need to find mean and variance. So just now we know that mx of t is e power t by 2 minus e power t, and my mx dash of t, just now we find what it is, 2 e power t 2 minus e power t whole square. So it's my responsibility to find what? My mx double dash of t. In this situation, for mx double dash of t, I don't want to simplify because I don't need further. Here I simplified mx dash of t because I want to find the second derivative. So again, u by v rule, 2 e power minus t, already it is whole square is whole power 4. Now the same, v du whole square into 2 e power t differentiation is 2 e power t minus, this time I'll keep this 2 e power t as it is. Then when I differentiate this, I'll be getting 2 minus e power t, then 2 minus t e power t is minus e power t. That's it. So in this situation, you don't want to differentiate, or you don't want to do third derivative. You don't want to do the third derivative. So what you are going to do, don't simplify. Now my aim is to find mu1 dash. Mu1 dash is what? Mx dash of 0. My mx dash of 0 is what? Simply put t equal to 0. So we know that what? E of 0 is going to be 1. So when I use this, I'm going to get what? The answer immediately. So my numerator is e power t, that is e power 0 is 1. Here 2 minus 1 is 1. 1 square is 1. So 2. My mu1 dash is 2. Now let's go for my mu2 dash. It has such big equation, but nothing. My denominator will become 1. 2 minus 1, 1. 1 power anything is 1. So 1, 2 is there. 1, 2 is there. 1, 2 is there. So here 1 minus and here 1 minus. So we'll be having what? Sorry, yeah. Mx double dash of 0. So in the first term, I'll be having 1, 2, minus into minus plus. Second term, I'll be having 2 2's. So when I put t equal to 0, this is 1, 1, 1, 1, 1. So it's going to be 6 guys. 4 plus 2, 6. So now I found my what? Mu1 dash and mu2 dash. And as I said, if nothing is given, my mu1 dash is my mean. That is going to be 2. Then my variance is mu2, and the formula for mu2 is what? Mu2 dash minus mu1 dash whole square. So my mu2 dash is going to be 6, and my mu1 dash is going to be 2. 2 square is 4. 6 minus 4 is again what? It's going to be 2 guys. So in this problem, what we found? We found the mean and variance. Both are going to be what? The same data. What it is? It's simply 2. So students, now I think you are confident with what? How to solve a problem when the discrete random variable is given. That is, to find the moment generating function for a given discrete random variable, and from moment generating function, how you find what? Mean and variance. Hope you are confident now to do the problem in this kind. Okay, now let me go for the problem on continuous random variable. Okay, continuous random variable. Then we are confident to do whatever the problem comes for our examinations. Okay, I am choosing a problem for you guys. Okay, let's go. Take down a problem. A random variable x, I'm saying a random variable x, the function f of x is equal to 2 e power minus 2x, x greater than or equal to 0. Find the MGF, then mean, then variance, then finally you have to find first 4 moments. First of all, tell me whether it is discrete or continuous random variable. Just now in the previous problem I said when x greater than or equal to 0, something kind of this, I cannot say it is what? Countably infinite. It becomes uncountably infinite. So what is my decision? I will say this, that given random variable is a continuous random variable. Done. So when it is a continuous random variable, we have to integrate. So that's what comes into our mind. Okay, let's go. So first let us find the moments in as usual way. Okay guys, let's go here. Mx dash of t. So we know the formula, minus infinity to infinity e power tx f of x dx. Since my limit is greater than or equal to 0, I am going to write 0 to infinity e power tx, and my function is 2 into e power minus 2x dx guys. So I'll take this 2 outside, 0 to infinity. Now this is the big issue. Whenever we integrate, we should be very careful what we are doing, because infinity is there. We know e power infinity is what? Infinity. E power minus infinity is 0. So now you see, whenever there is an infinity, when you integrate, you try to write something better like this. You will have some data with the integral like value x, because we are going to do a dx, and then always a negative should be outside. So that is better. So now in this case, I will take what? X, because I am going to integrate with respect to x. I'll take this x outside. It became t minus 2, but the thing is I want to a negative outside, so I will say 2 minus t. Is it okay? That's it guys. And now the problem is simple. Integration of e power ax is what? Yes, integration of e power ax dx is what? E power ax by the constant a plus c. So now 2 times e power minus 2 minus tx divided by minus 2 minus t will be having 0 to infinity. So now we know e power minus infinity is 0 and e power 0 is 1. So 2 divided by 2 minus t, when I put the upper limit, it will be e power minus infinity, lower limit is e power 0, and this is going to be 0 and this is going to be 1. So when I simplify, 0 minus 1 minus 2 minus t. So now finally I found the moment generating function, guys. So my mx of t is going to be 2 into 2 minus t. Done, guys. So 2 divided by 2 minus t is my moment generating function. Okay. So now what I found, I want to find what? My mean, my variance, and then I have to found the first 4 moments about the origin. That means you can do what? The differentiation 4 times. Okay, let's go. Okay, so now let us write. I found the moment generating function. My mx of t is 2 by 2 minus e power, sorry, 2 minus t, sorry for t, 2 minus t. And do you remember, guys, what is the derivative of 1 by x power n? The derivative of 1 by x power n is minus n by x power n plus 1. While the derivative of x power n is simply what? N x power n minus 1. So now mx dash of t, so 2 is constant, it's look like 1 by x. 1 by x differentiation is minus 1 by 2 minus t whole square, and 2 minus t differentiation is minus 1. So it is going to be 2 by 2 minus t whole square. Okay, this is one of the way. This is my mx dash of t and mx double dash of t. When I go for the double dash, so 2, now 1 by x square differentiation is minus 2 by 2 minus t whole cube, and 2 minus t differentiation is minus 1. So it is going to be minus into minus plus 4 by 2 minus t whole cube. Is it clear, guys? So now what I'm going to do, I'm going to find what is mean by like mean and variance, and then finally we are going to find the first 4 moments. Okay, let us find this. I think it's very simple. You can substitute and find what? The values by yourself. It's very obvious. Okay, guys. What is my, do you remember? My mu r dash is equal to mx r of 0. Mx r of 0. Okay, so yeah, let me do it. It's very simple, because there are some weak students, then they will suffer. So my mu1 dash is going to be simply what? When I put t equal to 0, it will become 2 by 2 square. It is going to be 1 by 2, that is 2 square by 4, 1 by 2. My mu2 dash, when I put t equal to 0, 4 by 2 cube, so 4 get cancelled. You'll be having what? Again 1 by 2. So my mu1 dash is also 1 by 2, and my mu2 dash is also 1 by 2. Okay, good. So from this I can easily found my variance. What is my variance? Variance is going to be 1 by 2 minus 1 by 2 whole square, that is mu2 dash minus mu1 dash whole square. So half minus quarter is quarter. That is 1 by 4. Right? So my variance is 1 by 4. As I said, nothing is given. So my mu1 dash, the raw moment, it is going to be my mean. Okay. So my mean is 1 by 2 and my variance is 1 by 4.